So why did we learn how to factor in the first place? Well, number one, it's part of our course, and then number two, the whole point of algebra is learning how to find our unknowns, and so it takes us back to solving equations. Now, we have solved linear equations, multiple linear equations, which means we didn't have any exponents aside from one. So now what we're going to do is we're going to use our factoring techniques to learn how to solve quadratic equations. So a quadratic equation is one that can be written in the form ax squared. So this is how we know we have a quadratic, if you have a squared term, plus bx plus c is equal to 0, where a, b, and c are real numbers, positive or negative numbers, and a cannot be 0. So the form ax squared plus bx plus c equals 0 is referred to as standard form. So if I say we need to write the equation in standard form, then you know what we're looking for. Ax squared plus bx plus c has to equal 0. So once we have our quadratic written in standard form, we're going to factor that. And when we factor it, this is what's going to happen. We're going to have two or more, possibly more, factors. So in order to solve the equation, we're going to use what we call a zero factor property. So zero product property, basically. So basically what that says is a and b are real numbers, and if a and b are a times b equals 0, then either a has to be 0, your first factor has to be 0, or your second factor has to be 0. And the reason being is because we know anytime you multiply anything times 0, your answer is going to be 0. So in order to solve these quadratic equations, we're going to factor them into these factors. And then we're going to take each factor and we're going to set them equal to 0. So you take your first factor, x minus 4, set it equal to 0. And then you take your second factor, x plus 2, and set it equal to 0. And then now you have two linear equations that you guys know how to solve. So we're going to solve both of these. For this one, you know you would add 4 to both sides, and for this one, you know you would minus 2 from both sides. And so these are your possible answers. Okay, so let's try this one. So what we're going to do first is we're going to set each factor equal to 0. So notice we have these two factors. We have y times y plus 3 equals 0. So you're going to take your first factor of y, set it equal to 0. Or we have y plus 3 is equal to 0. Now y equals 0 is already solved for, so we know that 0 is one of our answers. We also know that we can take this linear equation and we can minus 3 from both sides and get negative 3. So your two answers are going to be 0 and negative 3, and then make sure you check to make sure you got the right answers. Okay. So here are your steps. Solving quadratic equations. What we're going to do is we're going to write the equation in standard form. Make sure you have it standard form. It's got to be set equal to 0. So on the left hand side you want it in descending order, and then on the right hand side it's got to be set equal to 0. And then you're going to factor the quadratic completely using those factoring techniques that we talked about previously. You're going to set each factor containing a variable. That's important. Take each factor that contains a variable and set it equal to 0. If it doesn't contain a variable, just throw it out. You don't need it. Then you're going to solve the resulting equations and then check each solution and make sure you got it right. Alright, so here we go. Sorry. So we have x squared minus 3x minus 18 equals 0. Now, this is going to help us with our factoring techniques, because what you've got to do is you've got to identify what type of polynomial you have. I have 1, 2, 3 terms. So I have a trinomial, and my leading coefficient is 1. I know it's not a perfect square because I can't take the square root of 18. So to factor a trinomial where my leading coefficient is 1, I'm going to open up two sets of parentheses. And remember, it's still set equal to 0. You cannot start this unless it's set equal to 0. Then I'm going to decide on my signs. My signs are going to be different, and the reason being is because of that negative. And then I'm going to take the square root of x squared, which is going to be x. And then I have to think, remember, what can I multiply together to get negative 18? But subtract to get negative 3. So I have the 1 and the 18, that's not going to get it. 2 and 9 and 3 and 6, that's going to give me the 3. And remember, the bigger number has to carry the sign. So I have a -6 and a +3 is going to give me those numbers. Now, I'm going to take each one of these and I'm going to set them equal to 0. And then I'm going to solve. And so my two answers are -3 and 6. And again, you can check them if you want to. -3 plus 3 is going to give me 0, and 6 minus 6 is going to give me 0. Alright, let's try this one. Notice it's not, first of all, it's not in standard form, so let's add 16 to both sides. So we have 9x squared minus 24x plus 16 equals 0. So now we're ready to go. There's nothing in common here at all. So I have a trinomial. I want to say that it is a perfect square trinomial because I can take the square root of the first and the square root of the last. So let's try that. Remember, that's going to factor into a binomial squared. Match the first sign. Square root of 9x squared is going to be 3x. And the square root of 16 is 4. If I multiply those two together and double it, 3x times 4 is going to be 12. Doubled is going to be 24. So that is a perfect square trinomial. And then remember, I actually have 2 because of this square. So I can take each one of these and set them equal to 0, but I'm going to get the exact same answer. So here, if I add 4 and divide by 3, I would get the exact same thing if I did this here. So my answer is just going to be 4/3. Alright, so for this one, again, it needs to be put in standard form, so we're going to minus 24 from both sides. And so I have x squared minus 5x minus 24 equals 0. Okay, so there's nothing in common. This is a trinomial. My leading coefficient is 1. So I'm going to open up two sets of parentheses. My signs are going to be different. X squared is going to go into x and x. And what can I multiply together to get 24 but subtract to get 5? So let's see, 2 and 12 is not going to give it to us. 3 and 8, that's what it is. A bigger number has to carry the sign, so the 8 is going to go here, and the 3 is going to go here. Still set equal to 0, so we're going to take each one of these and set them equal to 0. And then solve, so we're going to have x is equal to -3 and x is equal to 8. So there's my answer. Okay, so let's look at this one. It's not set equal to 0. And it's not as easy as just minus and 5 from both sides because we have these parentheses here. We don't need to factor anything that already has parentheses. So let's distribute first. So we have 4x times 8x is going to be 32x squared. And then 4x times 9 is going to give me 36x. Now I can move the 5 over. So we'll minus 5 from both sides and get that. Okay, so we have a trinomial. Our leading coefficient is not 1, and I can't take the square root of any of these, and there is nothing in common. So I'm going to have to do the bottoms up on this unless you want to use a different method that you already know. So I'm going to take the 32 and I'm going to multiply it into the 5. So we're going to have x squared plus 36x minus whatever 32 times 5 is, 160. Okay, I'm going to factor this. Signs are going to be different. So split that x squared into x and x. Now, here comes the hard part. What can I multiply together to get -160, but add together to get 36? Well, to get that 160, I did 32 and 5. We're subtracting to get 36, so that's not going to give it to us, so we're going to have to go bigger. I mean, you can try the 16 and the 10, but again, the signs are different, and we're subtracting, so that's definitely not going to give us the 36. So let's try 160 divided by 2. That's going to give us 80 and 2. That's not going to be it. Let's do 160 divided by 4. That's going to be 40 and 4. That's it. Alright, so bigger sign has to carry the number, so our bigger number has to carry the sign. So we're going to have a 40 here and a minus 4 here. Now remember, we're doing bottoms up, so we're not finished when we get here. We've got to divide what we multiplied in initially, which is going to be that 32. Alright, so we're going to reduce. So 40 and 32 will reduce by 8, so let's do 5/4. And 4 and 32 will reduce by 4, so that's going to be 1/8, still equal to 0. Let's bring the bottom up, so we'll have 4x plus 5 and 8x minus 1 equals 0. Take each one of these, because we have an equation, and we got to solve this equation for x. So here we're going to get x is equal to negative 5/4, and here we're going to get x is equal to 1/8. So there's your two answers. Alright, we got one more to go. So for this one, it's already set equal to 0. It's in descending order, so I'm ready to factor this. Now, there is something in common. This is a binomial. Remember your binomial. Either 1 you have a greatest common factor, or 2 it's a pattern. Well, the only pattern I could have is the sum or difference of two cubes, and or squares, and I can't take the square root or the cube root of either one of these. But there is a 3x in common, so I'm going to take that out. And if I take a 3x out of 3x cubed, I'm going to get x squared. Minus, and if I take a 3x, divide a 3x out of 12x, I'm going to get 4. Now look at this. Inside x squared minus 4, that's the difference of two squares. So it's going to have to factor again. So the difference of two squares, open up two sets of parentheses, put a plus in one and minus in the other. Square root of x squared is x and x. Square root of 4 is 2 and 2. Now remember, at the very beginning of this, it said to take each factor that has a variable and set it equal to 0. Well, in this particular problem, we have 1, 2, 3 factors, and all 3 factors have a variable. So I need to take all 3 of these and set them equal to 0. Do you remember what would happen if you didn't have a variable? You would just throw it out. So for example, if I had just factored out a 3 here, then I would just throw out that 3, not use it. Your factor has to have a variable in order to use it. So let's change this back. Alright, so if I take 3x equals 0 and solve for x, I'm going to get x equals 0. Here I'm going to get x equals negative 2, and here I'm going to get x equals positive 2. So you have 3 answers.